Okay. I am currently recording. Is it good?
Yeah.
Okay.
How about I get a Oh, I'll put it in notes now because I have the YouTube link as well.
What the hell is this? This is beautiful. This is beautiful.
Get me inside a date, but it always not working.
It works, I promise.
That is really funny, actually.
This is ironic. Oh, it's just my mouse on this.
That's so weird.
Oh, well.
Please let me mouse.
Oh, I've had this happen before where I have to do two fingers. That's so weird. This happened to me on YouTube. Yeah, I don't think it's for this.
I don't think I've had that happen to me or something. Maybe in XOS it's just it might be in
It might be an configuration. Yeah,
No, it's a bait.
I was thinking,
I just saw
I
it.
transitioned one across to
When is that?
I don't know.
Just
Scroll down.
Oh, so this is 4 years ago. So this, I wonder if this is old
State
song.
packages.
What?
A lot of them have like more
Rapid
version
Blush.
known.
Oh, it totally is.
You know, just like little things.
Window.
It's just little things
Is
like
this
the
oldie song?
encryption thing is like in the center.
I don't know. Yeah, that's a turret. Because that's the turret there.
It's gotta be.
In the background.
I have one that
It totally has to. Hunter, is this oldie song?
It's just
Yeah.
but mine's Steam.
I honestly don't really remember what it looked like.
I thought it was Panaheim for a second. Like,
It might
no
be.
way.
Yeah.
They got-
'Cause-
This is no. It's 100% Esol. Yeah, this is Esol. Weird. So this is a clip about DSU offering on-campus tours.
So
of
it's a
Summit.
tiling window manager, right?
100,000.
Basically it means like when I open a
Weird.
window.
That's not 100 though.
No, it's
Yeah.
around. But right now there's the rooms here. The
100 or 200 something.
Yeah.
What's my
I mean, I'm a sinner and I use title bars.
Okay. Oh, I know exactly what this is. This is yeah.
But
200 something.
Yeah, because they have the study room there right now, which has
That's right. Well, I have a
weird.
and then I have like
Not that bad. Here's
so that like tiles it. I'm used to the Windows keeping on the other side because that's where it is on my desktop. I mean, the thing is, I'm always constantly tweaking it. If I go to my Coke
You're trying.
my Cobird repository for reviews and licenses. You can see I've been working on this for a
There's less than
while.
less than.
I'm about to
Tell me I'm wrong, Ryan.
Just comes every other hour or
I commit like every little change I can make. It goes all the way back to 2023, and it's even older than that because it used to be on GitHub and now it's started. I mean, no, that would be about it.
I think we'll wait a little longer.
So, but yeah, and it's still, you know, it was funny because like if you look, there's like this huge tab, like, you know,
So the one of those that. Oh,
like,
sorry. Excuses.
yeah, so
I was
there's like
tempted to send
three
it to
months
Corman
out,
tomorrow
right?
and be like, sorry.
Like during winter break.
Because Corman would totally.
But now that
Corman
it's
I could
gonna
get
be
away
here
with.
still, I don't think so. I haven't really had any issues with. I had issues when so this is actually Google XOS and Windows 11. I had issues with my Windows 11 because I didn't network somewhere and so it's screenshot by
Straight up.
So, you know, I
Hunter.
Mhm.
Joel runs ARL, right?
What was that?
Joel. runs
Yeah.
Okay, that's what this is about.
No,
Joel's a good guy.
I don't think I've had any related issues. The only
All right.
one issue I had was
Just to make sure, everyone should do the attendance. That's how we get money and other things.
What money? We don't even get our free sweatshirts for doing attendance this year.
There were sweatshirts?
Where are the CBTC jerseys?
Uh,
I've got the. Okay.
That should be a rain question. Yeah.
We're doing Hawaiian shirt day this year. Day 1 or day 2?
I've had basic Wi-Fi.
Day 2?
Yeah.
We show up in suits day business day 1.
Everything needs a
Hawaii,
Yeah.
what are you on? What are you using? Art?
All right, I think we're probably going to get started. If you haven't done so already, make sure to scan the attendance. I will unfreeze this really quick.
Full business formal.
Oh, there it is. There we go. Okay, is that? Sweet. All right, so today, this might be like a two-part, depending on how it goes. But today we're going to be just doing like Active Directory exploitation. But before we do get started, CTF Club is looking for more interns. It's like a leadership opportunity and stuff like that. You just need to be dedicated. You don't have to know like a whole bunch, just as long as you're willing to learn. Yeah, the commitment isn't very high, but yeah, just kind of reach out to like one of us really. I know some of us would be graduating, me included, so I won't be here next year for CTF Club or anything. But yeah, if you are interested in doing the club stuff, it's a lot of fun. But yeah, you can just reach out to any of us, Yuri, Leah, me, Gwen, probably Gwen. Yeah, Gwen's still around. But yeah,
She's like a
just like
not
floats
fly on the
around.
wall. More annoying than a fly.
Yeah,
She's like a mosquito.
but
In a good way, guys.
right.
In a good way.
So today's agenda, yeah, we're going to talk about Active Directory, but I wanted to preface this and say that AD is huge. It's going to be impossible to cover everything in 1 or 2 meetings. There's way too many services, different types of things like that. So we're just going to focus on ADDS, which is the domain services service in Active Directory. And it's also like the attacks and the vulnerabilities and stuff like that are going to be based around the CTF challenges that I made for the Active Directory stuff. So it's going to be like the scope's going to be a little bit more limited, but hopefully it'll be like a pretty good introduction into like what this actually is. So this is kind of the structure. So we'll start with like what it is, enumeration and footholds, post-exploitation, Kerberos, and then common vulnerabilities. And then at the very end, I have like a whole bunch of additional stuff if you are curious. And the slides will be available. One other thing is we need a good Active Directory pen testers. Windows is still the standard. Everybody uses it. Governments, hospitals, schools, airports. It's everywhere. And if you have massive Windows networks, you have like it's basically like a 100% chance that they're using Active Directory. And if you're doing like pen testing and stuff like that, it's what you're going to see, and it's probably going to be the most common thing that you will see, depending on if you're doing internals and stuff like that. And one thing that's like slowly changing but slightly unfortunate is offensive Active Directory isn't really taught here. But that is, yeah, like again, it's slightly changing, and it's also very cool because I'm slightly biased. Active Directory is probably my favorite thing. So what it is it's a directory service made by Microsoft that essentially manages basically network administration for a bunch of Windows computers in like a very centralized directory-like way. So this is like the Active Directory groups and computers or users and computers thing. It's literally it just looks like folders, and you can organize things different ways, and then you can apply what's called a group policy to essentially change how all of them are like permissions and different configurations and stuff like that. Some basic components, again, this is just mostly for ADDS. So ADDS stands for Active Directory Domain Service. The domain controller is the actual computer that runs that service. The domain is like a collection of objects and stuff that are in an Active Directory network. An item or like an object is an item that can be stored and cataloged in it. Organizational units in Active Directory are groups of objects that you can apply like permissions and stuff to. LDAP is essentially the way that you can map these things. So like if you have an object, LDAP will do the handling for saying like what your permissions are for that object. It'll basically map out all of the relationships in the domain. And then a tree is just a collection of different domains. So if they're joined by what's called the trust relationship, you can have multiple like networks and stuff. So for example, if you had like a domain for one site, so like if you were a massive enterprise and you had a completely different office or building, those could theoretically be two different domains that you join with a trust relationship. And then a forest is just a collection of trees. So then some common users in Active Directory. So the administrator is the domain admin. The guest is like a standard guest user. It's not always enabled by default, but sometimes it is. Anonymous is very similar to the guest user. This one's kind of weird because it's not really like documented as much as the guest user. KRB TGT is the Kerberos service account. This one would be very, very important later. And then local admin, so if you are not on the domain controller, if you're like a Windows system that's connected to the domain, the local admin is technically a separate user. And then computers are also accounts. So if you can get like machine account passwords, you can also just interact with the domain in the same way that you would if you had a user. And then these are some of the different ways that domain controllers may store like credentials. So NTLM is still around. It's like a very old legacy like protocol, and it's vulnerable to hash forwarding. We'll talk about that more later. To prevent that, they came up with NTLM v2, which is no longer vulnerable to pass the hash, and it's slightly more secure. DCC2 is domain cache credentials, and this is essentially like a backup. So like if the domain controller were to like explode and be no longer available, some like Windows computers will actually host their own DCC2 hashes for different users that have previously logged in. So if it's a resource that they commonly access, you can still log into that computer with the domain account without actually needing for the domain controller to be up. Kerberos is a ticket-based authentication protocol, and this is probably the one that's becoming the most like widespread. It's the most secure out of all of them, and yeah, it's also very cool, which is we'll talk about that more later. So one other thing is if you have multiple domain controllers in a network, they need to sync all of the credentials, all of the like relationships through LDAP. Everything that goes on in an Active Directory domain needs to be basically regularly synced. So if you log into one or the other, there wouldn't be any mismatch in like permissions or existing users or any configurations, things like that. So that's what's called a DC sync. It's also called a secrets dump from like the attacker's perspective, and that's kind of where we're going with this. And essentially, basically, your end goal if you're pen testing Active Directory is to just think of the DC sync as your end goal. So if you can pull off like a successful DC sync attack, you will then dump everything out of the domain controller. That is like all of the hashed passwords. A lot of times there are plain text credentials in there. You'll pull out like keys for what's called like DPAPI and stuff like that. You'll pull out the machine account credentials, like just pretty much everything. And yeah, it's completely game over if you can get like a successful DC sync. So with that, we're gonna go through some very basic like Active Directory enumeration and how to get like some footholds into various computers that way. So this is pretty similar to just like what you would normally do when you start doing like reconnaissance. So if you're doing like web or internal stuff with like Linux or whatever, you'd always start with seeing like what's actually on the network. So you would start with fping, nmap, etc., stuff like that. Some key ports that are on domain controllers. So DNS servers. Domain controllers usually are the DNS server for the domain. Kerberos is on port 88. 139 and 445 are used for SMB. 135 and 593 are used for RPC, and then LDAP has 389 and 636. 636 is actually for like LDAP S, which is like the TLS. I think it's TLS, but that one's also there. And then some common tools. There's a ton. This is not an exhaustive list in the slightest, but some of the most popular ones are NetExec, Impacket, Bloodhound. KRB Relay is kind of there, and then I'm sure we've all heard of Mimikatz and Rubius. Those are also tools that are used for attacking AD. Certify is another common one, but that's not for Active Directory domain services. That's for certificate services, which we won't really get into. So when you're doing anonymous guest or when you're doing SMB enumeration, like on the network, SMB is specifically what's used to share like files, printers, and other resources between Windows systems and with the domain controllers. And guest and anonymous SMB is a very, very common misconfiguration where either the guest user or the anonymous user is enabled. So essentially what that means is this is like one of the first steps that you'll go with, and just do like guess and just spray it down the whole network. I guess it depends on if you're trying to be quiet or not. But a lot of times this will just sometimes be the very first step. Like guest is a default user. So a lot of times it's turned on, and you can get just like low level access into almost everything with the guest or the anonymous user. So one thing that we're going to do, we're going to demo a little bit of it. So I have an Active Directory environment spun up in like my home lab right now. So this will be the network this will be the network that I'm attacking. Let's see. How big is that text? It keeps jumping around. Anyway. So we'll hit this. And then, okay, no, it's not really formatted very nicely. What we can see here, so this is on SMB. So this is essentially just trying to fingerprint everything that's running like the SMB service. So we can see that there's the Marine host, King's Landing, Winterfell, Castle Black, and Bravos. It'll also give you some like version numbers, what type of what is it running, Windows Server, like Pro, Home, whatever. And again, it'll give you like the host name, and then it kind of like truncates here, but you can see the domain. Let's see if I can. Yeah, I know, right? Here we go. So this one's a little strange. So this is like the kind of thing where I talked about having two domains joined with a trust relationship. So the Essos domain and the Seven Kingdoms domain are both joined with a trust. So there's two separate ones in this network, but you can see like these are the IP addresses of the systems that are running it. You can see what domain that computer is attached to, and then there's also some other security things regarding SMB that we'll talk about shortly after as well. But yeah, that's just seeing what's on the network. And then if you want to do basic, the SMB share enumeration, you can do the tac shares with the guest user. So I guess we can also do that here. Oh, there we go. Already filled in. Did I spell that wrong? I spelled it wrong. Sometimes you don't even need to type in the name wrong, because that'll essentially be just like, here, we'll type it wrong, or right, just for. There we go. Okay, so it looks like the guest user is turned on for Castle Black and Bravos, so you can see what your permissions are for these shares. Okay, so now with that, like, what are some things that you can do after? So, well, that's kind of what we'll go into next. This is again for anonymous, but pretty much the same screenshots of what we just did. Oh, okay. I guess I'll talk about that in a second. So the second one is RPC. So SMB and RPC are very, very important in Active Directory. So SMB is how like things like files, resources, other things like that are shared. RPC is how they actually like communicate. So like sending and requesting services to one another. A lot of times SMB and RPC will be used at the same time. But anonymous RPC is another misconfiguration where these two registry keys, I'm pretty sure they're registry keys, restrict anonymous and restrict anonymous SAM. If those are gone, then you can do very, very similar things with just basically logging in without a user. So if we do that here, and we just get rid of the username. So basically what this will do, and this is kind of confusing because we're using netexec with the SMB protocol, but the user's flag, and I'm saying that it's RPC. It's because netexec's user flag actually uses what's called the SAM RPC. So it is using RPC even though you're specifying SMB. It's kind of weird. But anyway, if this works, this is actually a very important one. This one's a little bit less common in when you're actually doing engagements, but you can see here on the Winterfell, this is the domain controller, by the way. So right off the bat, now we basically have anonymous access, and we just dumped all of the users out of the domain. So from there, you can look for other misconfigurations now that you actually have access to all of the users. There's another vulnerability where it's common for people to put passwords in the user description. So just like here, you can see, so this Samuel Tarley user, whoever administers this domain, they had this misconfiguration where they put their password in the description. Because a lot of people tend to think that you can't see the description, but if you can dump it all out, then you can see it. So now we have credentials, and it basically took pretty much nothing, just common misconfigurations that exist already in Active Directory and Windows. So these are the same things. If you want to use RPC client, it's a little bit bulkier, but if netexec for whatever reason tends to be acting up, it's always good to have a backup tool. But netexec is the one that I always like to use. Again, this is the same screenshot for what that looks like. This is technically LDAP enumeration as well. That's how you were able to find various things. Okay, this is the third most common thing. It's called LLM&R. This one's slowly being phased out, but this is a very, very, very big one. So it stands for Link Local Multicast Name Resolution, and essentially what it is it's a fallback for DNS. So if we look back here, and you can see that all of these have like their own host names and stuff, and then like with the domain. So like for example, this one would be bravos.sos.local. That's how a lot of like Active Directory systems will, or systems in Active Directory will refer to each other. They'll basically call each other by the actual host name, and then they can start to go ask for like the resources and stuff. So that DNS resolution needs to happen somewhere, and that happens on the domain controller. But if the domain controller or the DNS service, for whatever reason, ever were to go down, and you can no longer resolve those IP addresses to host names, LLM&R was supposed to be a fallback for that. And basically what it will do is if DNS goes down, if it can't find that resource, it will then just broadcast out to the network using LLM&R saying, hey, where is this thing that I'm looking for? So you can see that here. So this is using a tool called Responder. We'll also talk about that later. For hosts that have LLM&R enabled, you can just start spewing it and essentially poisoning the network, and then they'll all respond if they have LLM&R enabled. So then even if like DNS is properly working, they'll also just start responding to you. And then they'll also start requesting stuff as well. So in this case, you can see 56.11, which is that Winterfell controller. That one wants to connect to Bravos. You can see that LLM&R thing because it's being broadcasted everywhere. So from an attacker's perspective, there's no verification with LLM&R. So with like with DNS, like you have that central trusted resource where you will see like what host name is linked to this IP address. But with LLM&R, it's basically whoever just responds first. And the thing in LLM&R is like technically if you're not the computer, they won't respond. But as an attacker, you will respond to all of them. And from there, you can start to man in the middle various sessions. So let's say, for example, like this 23 system wanted to reach out to like some other computer or whatever. And they broadcast it out on LLM&R saying, hey, I'm looking for this resource. Our computer using Responder will say, hey, I'm that resource, authenticate to me. And then what they'll do is they'll authenticate to us, and then we will now have control over that authentication flow, and then we can relay it to the actual destination, and now we have a man-in-the-middle session. So we can then assume whatever the user's permissions are, and we can just ride on that connection. And yeah, they would have essentially no idea, but we would just be intercepting the whole thing. So there are some like prerequisites for this. It requires SMB signing to be turned off. That's a security setting that isn't always turned on with like Windows computers, but on domain controllers it almost always is. But yeah, this is the most common vulnerability in Active Directory and Windows. And so just I guess a fun little story. So when we started doing like the Project Boundary stuff in the Mad Labs, and we had like counties and cities and other things like first come in for the first assessment that they were doing with it, or like the first pen testing assessment that they've ever done. Almost every single time on the first engagement, we would just get instant domain admin because LLM&R is on. And it's a default setting. It's turned on every single Windows computer. It's slowly being phased out. I think Microsoft is slowly like making it default like turned off essentially, but that's not the case yet. So pretty much if there's a Windows computer on the network, if they're trying to access something, they're going to use LLM&R. And yeah, so again, this is what it looks like when you abuse it. You will get like hashed passwords in. So this is like kind of like the NTLM v2 password format that we were talking about earlier. But this is how you would spin up Responder and stuff like that. But that's what this would look like. Okay, so those are like just three like very, very common ways of getting at least some like foothold in the network. So that was guest SMB, anonymous RPC, and using LLM&R for network exploitation. So after you get some form of credentials, or you get a session or something like that, what are the things that you want to do next? So the first one, like kind of like what we saw here, this is a hash password using NTLM v2. You can crack that. So if the password is weak enough, you can pass that in with a normal word list like RockU or other things like that and see if you can recover that password. Kerberos tickets, we'll also talk about that later. pass the hash. It's very unlikely nowadays that like NTLM hashes will be thrown around the network. That was the very insecure one that we talked about earlier. But if you can get your hands on one of those, like you don't even need to crack the hash. You can just give it to the service, and they'll just take it as if it's the password. And then you can start like doing SMB enumeration. So you like connect to that share. Maybe they have documents. Maybe they have plain text passwords. What kind of things can you find on the computer from there? There's also shells you can spawn with RPC, kind of like the one that we used here. A lot of times you need to have pretty high privileges to spawn those, but it is a thing. Coercion attacks, dumping LDAP, and if you are an admin, that's the DC sync. If you can DC sync the domain controller, you pretty much won. So this is what it looks like to kind of like pass the hash. So this is an example hash of like an NTLM hash basically. So this is for that KRB TGT user. I think this is their user ID, and then this is what the hash password looks like. If you wanted to pass that, you would basically just get rid of the username and then these 3 colons at the end. So this is what your cleaned output would look like, and then that's what you would put in for the tools. And I should have mentioned this earlier. If I'm ever like getting very deep into like what the tool stuff looks like for commands and stuff, that's because it is required for like whatever challenge it is on the CTF thing. So just trying to have like a little bit of a cheat sheet here without making it too like over the top or anything. And then I said that the NTLM v2 and DCC2s, you don't need to crack those, but that's what it would look like if you were. Okay, so after you get access to like an SMB share or something, kind of like what we saw up here, how would you connect to it? So this is where Impacket and other tools like that will start to come in handy. Impacket has a tool called SMB client. Basically, you'd specify the user, the host. Usually you can do no password. If you want to do it with credentials, you just do it like that. But yeah, like it'll give you an SMB shell, and you have to first use the share. So you type shares, it'll show you what's available. And then after that, it's just like the normal Linux command line stuff like cd, ls, pwd. If you want to download a file, you can use get. If you want to upload something, you can use put. And you have to be in the same directory, like as in, let's see here. So I have this file called hi.url, I guess. So if we do like impact at SMB client, let's do it on 11. Disabled. Perfect. All right. That didn't work. What was the other one? 23. Okay. So we have shares. You can see these are the ones that we have access to. If we scroll up and see which ones we actually had permissions with, so we can use the all share. That's the only one that we can use. So if we do use all, now we can see what's in it. This is an empty directory, but that's how you would connect to shares. Oops. Okay. I guess that went a bit faster than I was expecting. Does anyone have any questions right away? Anything like that? Yeah.
I guess just to defend against those, it's basic SMB settings.
Yep. For which ones?
Just kind of for all of it, like you said, SMB signing, and then anonymous login.
Yeah. Yep. That's pretty much where all of them are going to be using is just like SMB, RPC a little bit. It's really only going to be used at least for the challenges for like dumping the users and stuff. But yeah, pretty much everything else will just be using like SMB for the most part, or some tool that uses it. I guess if we don't have any I could go into Kerberos. Sure. Okay. Well, actually, I guess just like who wants to do Kerberos really quick? Because this is kind of a big topic, and I don't know if we'll have enough time to like go through all of it, unless we want to just like jump to the challenges or something right away. Let's see. Actually, here, I will do this. So if you want to do the challenges, so the ones that we just went over will cover the all guests welcome, lemonades, donuts, and pie, and confused waiter. Those 3 right off the bat, you guys will have the resources to do. The next 3 are going to be Kerberos related. And also, I guess I should mention this too. If you haven't done the provision the environment yet, you can just go to the CTF club chat, and then it'll just be who wants a VM. Just click on that button, it'll deploy it for you, and then you can go to the link that it gives you, and then you can just start it all up. So you can do that. Yeah, I guess we could, let's see. How many slides are in here? I don't remember. Sure. Okay, I'll go over the Kerberos like authentication like flow. We'll just do that really quick. So like kind of mentioned earlier, Kerberos is the most common, or it's becoming the most common way that Active Directory environments, or Active Directory, holy cow, I can't talk. It's like the most common way that authentication will take place nowadays in Active Directory. It uses Kerberos, and it does what's called ticket-based authentication. And really the main difference between Kerberos and like your traditional authentication schemes are it uses a third party. So for example, like if you were to think of like when you wanted to like log in with to some server or something, or you want to access some resource, it would usually just be between the client and the server. But for Kerberos, they introduce a third party to make sure that it's the most like secure and stuff. We'll get more into details about it, but the big thing with Kerberos is that it assumes that nobody in the network trusts each other, and that's where the third resource comes in, because the client doesn't trust the server and the server doesn't trust the client, but both of them trust what's called the key distribution center, or the KDC, which is usually domain controllers for in Active Directory. But it's through those exchanges with the KDC that you can then gain trust to access the actual resource that you're trying to log into. So it's a little bit weird, but there's 5 or 6 like main steps for Kerberos. So you'll do what's called authentication service request. So let's say, for example, that like I am some user and I want to log into a server that's in my Active Directory domain. I don't trust that server, but I do trust the domain controller. So what I'll do is the user will reach out to the domain controller and say, hey, I want to log into this server over here. And the domain controller will say, okay, first you have to prove yourself. So you have to send your normal username and password to prove your identity to the domain controller. After that happens, that we then enter the step 2. So then with that, after you've proved yourself, the domain controller will respond with what's called a ticket granting ticket. And that's essentially the best way that I've heard this mentioned is like, think of it essentially as like a token. So if you have a ticket granting ticket that is tied to your user, and you can pass that anywhere in the network to essentially log in as that whatever user is tied to the ticket granting ticket. And when you the reason why that you have this ticket granting ticket thing is because you can hold it for an extremely long time and you won't have to re-log in. So you don't have to do the whole thing where you have to like submit your username and password and the domain controller verifies your identity. You can hold on to the ticket granting ticket for an extended period of time. I think it's like 72 hours or something like that. You can hold like the computers will hold on to it for a very long time. And the reason why that is because like the actual like encryption and stuff that goes on, I think is a lot more like there's a lot more heavy lifting that has to go on. And so being able to just hold on to a ticket granting ticket, essentially use it as a token, it's a lot more efficient. And so when you then want to generate what's called a service ticket, that's the thing that you will actually send to the destination server. You pass your ticket granting ticket to the domain controller, say, give me a service ticket, and then it will then give you a service ticket and go from there. So the thing that's slightly strange, and it took me a long time to get kind of used to with the way that Kerberos maintains its security, is that it relies on like secrecy or like not knowing another user's password. So the reason the ticket granting ticket is like, it seems kind of weird, but the reason why you don't have to go through the step of like verifying your identity anymore is because the ticket granting ticket is encrypted with the KDC's secret password, so that KRB-TGT user, and no one else in the network knows the KRB-TGT password except for the domain controller. So if an extended period amount of time, like an extended time goes by and a user shows a TGT, the domain controller will see that and say, no one else knows my password, therefore I must have like given that out at some point. And it can basically make that assumption off of the fact that no one else knows that password, if that makes sense. So theoretically, there are 3 immediate ways to attack Kerberos tickets. So the first one is asrep, so that's the one here. So when you go through this asrec and this whole process, there's a feature that will allow that password to be floating around, but that's encrypted with the user's password. The TGT is encrypted with the Kerberos password, that secret one. And then when you generate that service ticket, so when you pass the TGT back to generate the actual ticket that you want to log into the server, that will be encrypted with the destination services password. So there are 3 theoretical ways that you can essentially attack these things, but in reality, there's really only two ways. Like, good luck cracking the KRB TGT hash, because that thing is insanely long. It's a super long complex password, and there are 2 also settings that essentially have to be turned on for ASREP attacks and TGT rep or TGS rep attacks to work. So we'll go into that a little bit more, but yeah, I can explain this a little bit more. Like, does that kind of make sense? It's just kind of like a glosser over how Kerberos authentication works. Just like, I don't know. I'm not sure how well I explained that right off the bat. But let's see. Okay, I think we'll just keep going. So theoretically, this would be the first step. So ASREP. This is that first part where you can encrypt, like where the user will reach out. That message will be encrypted with its own password, and if the KDC can decrypt it with that password that it thinks it has, then that person has proved themselves. So pre-authentication is a setting that is not that's enabled by default, and disabling it is a thing for like backwards compatibility. So if you had like a service that doesn't support the full Kerberos authentication protocol, you can disable what's called pre-authentication. And basically what that'll do is it'll pass this like what's called this ASREP hash. So it doesn't have to do the whole like these 2 steps here basically. I don't know why that might not be like compatible, but this is for like legacy systems, I guess. If you can't do step 1 and 2, pre-authentication will just let this float around. And as a user, or as an attacker, if you have all of the users in the domain, like what we just did when we dumped it earlier, you can just request an ASREP hash and then crack that user's password, because it's more likely to be cracked, because, yeah, user passwords usually aren't super strong. But we can actually go through and quickly demonstrate what that would look like. So again, this would be kind of the path. So if you have anonymous RPC, again, this would be kind of like one misconfiguration by itself. Oh wait, wrong IP address. So .11, so we have these users. We can then just, actually, I'm gonna out this to a file, names. All right, now we're gonna do a live demo on my awk abilities. This is gonna be really fun. So we wanna do, and then we wanna print, is it 1? And then I need that what names? That's not it. 2. Okay, we're getting close. I'm just gonna add some spaces. Sweet. And we're gonna pipe that into, let's say, 5, and then we're gonna print. Is it 1? Close enough. Okay. And we're gonna call this users, and then we'll just clean up the rest of it. We don't need the guest user, we're gonna guess. Okay, cool. So after you have that list of users that you just dumped out from the domain controller, to find ASREPs that are, or ASREP hashes that are potentially floating around, you can use this tool called get NP users. So that means get no pre-authentication users, because that's that legacy feature, or that feature for, backwards compatibility basically. So if we do get users, you'll specify the domain. So in this case, the one that I'm attacking is this north.7 kingdoms domain, because the one that I hit was .11. That will change on the lab, but yeah, just slight template stuff. So I'm just gonna actually do that. Did I name it the same thing too? I did. So if we just send that, so we just specified, this is the domain controller we want to like dump the users out of for the ASREP hashes, and then this will just pass in all of the users here. it will just iterate through and see if they have no pre-authentication turned on. That's a weird way of saying it. But then, if one of them does, you can then take this hash and crack it and recover the password. So I guess that's one thing that we can do next too. So yeah, once you have the ASREP hash, you just pipe it or just put it into a file. So I'll just call it like ASREP. There we go. And then we want to use hashcat 18200, I think. If you're ever unsure, you can just do TAC H and just grep for like the specific protocol that you're looking for. Sometimes it takes a minute. So there's various Kerberos ones in hashcat. There's like a bunch of different types. Then the way that you can identify what type it is so for example, we just did an ASREP hash, but you can see there's like multiple TGS rep hashes, for example. When you actually look at it, there's going to be this little number here. So in our case, we have 23. I mean, it is the only ASREP one, so that's pretty easy to tell, but you would then pick the 23 one. So we're going to use 18200. So we do hashcat. And then we're going to pass in our not users, ASREP hash. And then we're going to do, oh, I didn't. Okay, try that one more time. Okay, now we wait. We're cracking passwords. Am I going too fast, or like, does this seem okay? Seem good? Good? Okay. I wasn't expecting it to be like 30 minutes in by the time we hit Kerberos. I was expecting it to be like 1 whole hour for both sections, but if possible, like I'm fine with doing it in like a full hour, just so you guys can do all of the things. And again, like the commands and stuff, that'll be not enough memory. All right, never mind. Anyway, but the commands and stuff that you'll need to use for the challenges are going to be on here. But yeah, well, that's what the cracked one is. I guess my VM doesn't have enough RAM, but so and then again, like now that you have this user's password, so you can kind of see it in the hash. It was for Brandon.Stark. If you can crack that ASREP hash, you can then recover their user password, and then you can then start repeating the whole process again, connecting to shares, seeing what they have access to, maybe if they have a high enough privilege, spawning some shells. It's just kind of just like you get credentials, restart the process, see if you can elevate, and just keep doing the same thing. So the second thing for Kerberos ticket attacks specifically is TGS rep. So again, just like kind of going back to this, the ASREP was the very first like authentication service request thing. So the TGS rep is the actual service ticket that's encrypted with the destination service's password. So in traditional like senses, if this was like a computer or something, that's going to be very unlikely that you'll be able to crack it, because again, like the KRB TGT user, computer accounts have extremely long and extremely secure passwords that are completely randomly generated, and the only way that you can get like a Kerberosable user, that's like the phrase for it, is if you set up what's called an SPN on the user. So I think I had it in this slide too. I guess I should have mentioned that earlier too. But the way that Kerberos like refers to things in the network is via like an SPN. So think of it just basically as like a host name and a service. So there's like a huge list of them. But for example, like let's say for this like Winterfell computer, like up here, if we wanted to RDP into it, the SPN would be like RDP/Winterfell. Or if you wanted to connect to like the SMB shares, it would be CIFS/Winterfell, which stands for Common File System or Common Internet File System. There's like a bunch of other ones, but yeah, that's basically how Kerberos kind of identifies like what you're going to be actually authenticating to. But you can also set SPNs to user accounts. Honestly, I don't know why you would do that, but it is like just a straight vulnerability if you can, depending on the strength of the password. But users are Kerberosable if they have an SPN tied to their account. And again, like that's how services can identify each other. And if you generate a ticket for that SPN, your ticket that you'll actually get back will be encrypted with that user's password. So if you can request a ticket for something tied to it, you can then potentially recover their password and then do the whole thing again. So I guess we can quickly look at what that would look like. So if we do, yeah, I'll just use this one. This sexy Wolfie. So this is Goad. This is one of the domain admins. Don't ask me why his password is sexy Wolfie. I can't explain it, but it's funny. But so basically, we'll take the domain, we'll take this user, and then we'll take their password, and then we'll ask the domain controller, hey, are there any SPNs that are available for us to authenticate to? And then you can request them. In Packet will actually filter out all of the machine account related ones. It'll only return the SPNs that are tied to a user account, because those are the ones that are most likely to be cracked. So if you do that, you can see we have 3 different ones. It's kind of messy, but here, this one is for the Sansa Stark user. This one here is for the Jon Snow user, and this one's for the SQL Service account user. And you can also see it up here. So, well, this one, that one's mine. That was something I was testing. But you can see kind of like here, so you can see HTTP with the service account, CIFS with the service account, SQL with the destination. But anyway, this is a second method that you can use to then pivot once again. So if there's an SPN set to a user, you can then pull these down and crack them. Because I don't have enough RAM, I'm not even going to try it again. But, and then just in case, so you will have to crack user SPNs for the lab, or for the challenges. But if you get this error, that's because the clocks might have gone like a little bit weird. Maybe like the domain controller fell asleep and the Kali box was still on, or vice versa. Like if the clocks start to skew and you try to do like Kerberos related things, it might freak out, because Kerberos really, really relies on the clock. So you can just use these commands if you get that error, and go from there. So that's how you can sync the clock with the domain controller, and then that'll work again. That's how you crack them. Oh man, okay, we're getting to delegation too. All right, am I going to, again, like I'm just gonna keep asking, am I going too fast? Because I feel like I'm going too fast. I was not expecting to get here in like one meeting. So I can do like a quick 101 on it. I won't dive into like the additional stuff very far, but they'll be available. But so one more time, like going back on what we know from Kerberos tickets is when you want to access some resource, you have to go through this whole process with the domain controller to then generate a service ticket. And that service ticket is going to be encrypted with the password of the resource that you're trying to access. So there are some limitations because of that, and that's what's called the double hop problem. So let's say, for example, you had like this was your computer, and you wanted to log in to say, like, let's say that was like a web server or something, and then that web server will then reach out to a database server that's located somewhere else to then see like maybe what your user permissions are, or like information about your, just anything like that. So the issue that with Kerberos and that type of like authentication flow is that as far as this computer is concerned, so this web server for example, when you log into it, the only thing it's going to see is a ticket that is encrypted with its own password. So it would know like what user is actually logging in, but it would have no idea what the user's password is. And that's kind of like the point of Kerberos, is to prevent passwords from like being thrown all over the place without them like needing to be, essentially. So that's what's called the double hop problem. And delegation is like an early solution, or delegation is the solution to the double hop problem. And there are 3 different ways of doing it. And the reason why there are 3 different ways is because if you configure any of these improperly, they are extremely dangerous. So the first one was called unconstrained delegation. Again, if we go back to when you get that ticket granting ticket, or that token of you basically proving that you've logged in, you can pass that and request a ticket for any other service in the domain. So if somebody else has your TGT, then they can do the same thing. It's basically the same as having their password. So the way that unconstrained delegation used to work is, if you needed to solve this issue here, you would set up unconstrained delegation on this computer, your user would log in, and then also give it that user's TGT, so then it can pass it to the resource that it needs to access. The problem with that, again, is if this server gets compromised for whatever reason and it's configured with unconstrained delegation, you can then take that and log in somewhere else. Like that wasn't the intended solution for that, but you can take it because it's a TGT, you can just log in anywhere else with it. And so let's say, for example, if you compromise this and a domain administrator logs into that computer, now you have domain administrative access. So to kind of prevent that, to prevent TGT forwarding, that's where constrained delegation comes in, and it introduced two proxies to essentially like act as a solution for this. And it's called service for user. So S for you to self and S for you to proxy. Basically, what this will do is if you configure constrained delegation on this, you no longer need to pass the TGT because that was the dangerous part. You can then basically just say, I want to become this user on this destination, and it would only work on that one. So if you, for this example, you would set up constrained delegation on this computer to only authenticate to this using constrained delegation. So again, like it kind of lessens the scope of damage, but it can still be extremely destructive because now this user can become any user in the domain to a single resource. So again, like if this was the domain controller, you're done. Or like now, if you have this computer and you have constrained delegation to another computer, now you can have administrative privileges over that one, and now you can do some other shenanigans, stuff like that. So you can use them for pivoting. It's like stuff like that, but it's kind of still a problem if, again, it improperly configured because it's just basically damage control at that point. Like delegation is useful, but very, very dangerous if you set it up wrong. And then the third one, this is a lot more niche. It's called resource-based constrained delegation. So the thing with that is unconstrained and constrained could be tied to a computer or a user. Resource can only just be put on a computer pretty much. So it's a lot less common to see like just configured in general, honestly. But there are ways to abuse that. I don't know of any realistic. So like for vulnerable environments and stuff, you'll see resource-based constrained delegation all over the place. In terms of like an actual practical deployment of it, I genuinely have no idea why you would even need it. Like at least for the way that they're set up for you to exploit. But anyway, this is how you abuse constrained delegation. So first you have to query it. So you can just ask LDAP what resources, like what computers and what users have delegation permissions. So if we were to do that here, I'm just going to use the same thing here. You can see here, so the Sansa Stark user has unconstrained delegation. That's very dangerous. Jon Snow, this person has constrained delegation, and they can only log in to the Winterfell computer. Same thing here. And then also the Castle Black computer has constrained delegation to Winterfell. So again, like if you can get this person's the credentials for any of these users, or if you can compromise that computer, if you basically exploit it correctly, you can become any user in the domain to whatever resource is specified here. And in this case, all of these are the domain controllers. That would be completely game over anyways. But this is how you would abuse that. And then this is like one of my favorite delegation memes. So it's like they told me I could be anything I wanted, so I became the domain controller. Again, this is not limited. Like if you go back to the very, very beginning, computers are also users. So you could become computers with delegation, which is the way that I would actually recommend you do it when you do constrained, because it's a lot more reliable for some reason. But yeah. So again, like just what to expect. Like you have all the commands in here for what you need to abuse and to complete all of the challenges. But this is just kind of a hint, like in case I went too fast or in case I didn't explain anything properly enough. 1 is just guess SMB. 2 is anonymous RPC and LDAP enumeration. 3 is LLM&R poisoning. 4 would be ASREP roasting. 5 is TGS rep roasting, and then 6 is constrained delegation. Out of the 3, that one's the most like realistic and like timely to exploit. But yeah, again, with that, like, does anyone have any questions or anything? Hopefully I didn't go too fast or anything like that. Like, I know. Like the thing that was kind of challenging when I was making these slides was because there's so much to talk about in like a fairly limited amount of time. Like I hope I'm being like at least detailed enough for these labs to be actionable. I have no idea, but yeah. Not to muddy the water or anything, but there's some additional stuff in case you're interested. These are RPC shells, so if you've ever been curious about that, here are some common ones, like WMI, SMB, AdExec, PSExec. NetExec can also do it. Here's some links. There's bigger ways to attack LDAP. So again, like if you remember back to how LDAP essentially manages all of the relationships of everything in a domain, you can use a tool called Bloodhound to dump all of that out, and it will just like physically map it all out for you. And it'll say like, and there are like predefined queries. So you can say like, start from this user and give me a path to domain administrator. And if all of the permissions and things are set up like in a way that that's possible, it will just tell you exactly what to do to escalate. So LDAP, Bloodhound is for massive networks at least, very, very useful because it just kind of helps to visualize like what the permission schema and everything looks like for the network that you might be testing. But this is very, very weird. And this is probably one of my favorite attacks. So they're called coercion attacks. You don't need to do them for the challenge. I just wanted to bring it up because it's huge in Active Directory. So basically the TLDR is if you have credentials, you can force a computer to log in somewhere else completely arbitrarily. Like it's just something that happens with RPC, and it's almost impossible to defend against because a lot of times the services that do that are needed. So like one of the biggest ones, like one of the biggest security problems with Windows is the printer driver. Like there's a print nightmare, so that's like a privilege escalation vulnerability because the driver will run at kernel level and it will reach out to the network and just load any driver. So if you can force it to do that, you can just replace it with an executable that's malicious or something, and now you have full access to that computer. For the coercion sense, they have another one called printer bug. So that will just use SMB and RPC to connect out somewhere, and you can just force it to log in. Those come very, very handy when you're hitting specifically, where is it? Unconstrained delegation, because depending on how you do the attack, it will actually pass the ticket granting ticket. So that's one way of forcing that to happen too. But coercion, yeah, you can just literally force a computer to log in anywhere. IPv6 is a huge issue in Active Directory environments too, especially if they don't set it up like, so IPv6 is turned on by default like on Windows and stuff like that, but a lot of times they don't have like the DNS servers or anything like that like configured, so they'll just they'll just go to anything. And also Windows prioritizes IPv6, so from an attacker standpoint, you can basically pull off what's similar to like an ARP spoofing attack or a GHCP spoofing attack, but it's like a lot more effective. So that's another one. Drop the mic is another interesting vulnerability, but these are just some additional stuff. Forced authentication. This is another really cool one. So this is not an extensive list in the slightest. I think John Hammond made a video on all of the types of files that will just do forced authentication by default, and I think the list got up to like 18 or 20 on Windows. So basically, depending on how, this is depending on how the file is, but I know for the URL files and I think SCFs, like you know the little icons or the thumbnails that show up on your desktop, if you specify that in the file like right here, and that's on like a network share, if that pops on your desktop, the computer will just log into it. So if you are that thing, that's just like a free way of getting hashes, and it'll show up in like Responder and stuff like that too. So that's what's called a passback or a forced authentication attack. Coercion vulnerability. It's really weird how you can just force stuff to log into you. Relays. So if you can control the connection flow of a different computer, you can then relay that somewhere else and do something very similar to the LLNR vulnerability like we talked about earlier. Again, that would require that SMB signing to be turned off, which a lot of times nowadays it really isn't, but it's still out there. This is what the relays look like, but NTLM relay is, again, like one of those super, super, super cool tools. It's probably one of my top favorites besides like NetExec. But you can do, it'll automate a whole bunch of stuff, and you can use them with passbacks or coercion or things like that. There are some other Kerberos attacks that I didn't talk about. So there are forged tickets. So there's silver tickets, golden tickets, diamond, sapphire. Really, the most common one is golden ticket. Like diamond and sapphire are ones where you're like probably more in like a red team engagement and you're trying to move very, very slow and be very quiet and try to blend in with the whole authentication flow. But all of them use very similar like things. So if we remember back to the on the Kerberos thing with how, oh, whoops, I went too far back. Where did it go? I completely lost it. Here we go. So how the ticket granting ticket, that token is based on the trust that no one else knows the KRB TGT hash or the password for that user. If you can get full domain compromise, you can get that user's password, the KRB TGT password. And that's what's called a golden ticket account. Because you can then just completely bypass those like the initial steps of authentication. So you can log in as a domain administrator for a user that doesn't even exist. Or you can become basically any user in the domain without ever needing to know their password because you've bypassed that authentication stage. And then yeah, unconstrained. Here are a couple ways to do it. That was like the host and the user one. Here's some stuff with resource based. There's some links for that if you're curious. And yeah, if you'd like to practice AD stuff, the environment that I'm using here is called GoAd. This is like a completely free thing to download. They have really good documentation and it has pretty much almost every Active Directory vulnerability under the sun. It requires quite a bit of like RAM to run, but if you have like 20 to 50 gigs of RAM lying around, you can totally spin that up and it's a blast. I don't know, and I don't do Hack the Box or Try Hack Me like very much, but I heard that they have some pretty good stuff with AD stuff, so I figured I'd drop those in here. So they have an AD pen tester role and things for compromising AD, and yeah, that was the whole 42 slides. So hopefully that made sense. Like hopefully that was entertaining at least. I hope it was a good at least like primer introduction into the different things you can do with Windows and Active Directory. Again, I'm slightly biased, but it is one of my favorite things. So, yeah. Does anyone have any questions or anything? All good? Cool. And then I'll throw these slides in the Discord as well, so you guys can refer to it. Let's see.